When I apply force here, then its velocity increases. That is, change in velocity takes place. Okay, its velocity changes when I apply force. Hello everyone, welcome to Incredible Study. Today in this video, we know about two topics, that is change in gravitational force due to variation in their masses and the distance between them. And next topic is acceleration due to gravity. And before this lecture, I have already published 5 lectures. So if you haven't watched such lectures, then watch it quickly, because this lecture is extremely dependent lecture, and you find the link of such lectures in description. So without getting delay, let's start our lecture.
Welcome to Incredible Study.
Here there are two cases. Okay, first, change in the gravitational force due to the variation in their masses. First we discuss when the masses change, but in this case distance remains constant. And second case, the distance changes but mass remains constant. Okay, so let's discuss these two topics. First one, change in, here first case we discuss change in the gravitational force due to the variation in their masses, but here distance remains constant. Distance between two bodies remain constant. This is first condition. Okay, and here we know, let us consider, let two bodies of masses m1 and m2 which are separated by the distance d. Okay, let us consider two bodies. First body have mass m1 and second body have mass m2, which are separated by distance d. Distance between them is d. So when this body have mass m1 and this body have mass m2 and the separation between them is distance d, then according to the Newton's universal law of gravitation, the gravitational force between them is given by, here in previous lecture we have discussed about this Newton's universal law of gravitation. So if you haven't watched, then go and watch it. Okay, so according to the Newton's universal law of gravitation, the gravitational force between them is given by F is equal to G m1 m2 by d square. This is the gravitational force between the body A and B. Let this body be A and this body be B. So this is the gravitational force between two bodies A and B of masses m1 and m2 respectively. Since this much is common in all cases, I am not going to repeat this statement in all cases. Okay, so case number 1. Here case number 1, when the mass of one body is doubled and other body remains constant. When mass of one body is doubled, when mass of one body is doubled, so here we write, since this is the gravitational force between the bodies, so when m1 is replaced by twice of m1. Twice of m1 means the mass of body A is doubled, that is 2m1. At previous it was m1 and now it is m2 according to 2m1. according to our question. So now we write here, then F inverse. This is gravitational force between the body when the mass of one body is doubled. That is G 2m1 m2 by d squared. Then now we write here F inverse is equal to 2 at first and G m1 m2 by d squared. So here we can write F inverse is equal to 2 times of F. This is first case. When mass of one body is doubled, then the gravitational force between such body is increased by twice as it was before. Okay. Now we going to discuss our next case, that is when the masses of both bodies become doubled. Okay. Let me write here case 2, when masses of two bodies are both bodies is doubled, then when m1 is replaced by 2m1 and m2 is replaced by, when m2 is replaced by 2m2, then we know F inverse is equal to G when m1 is replaced by 2m1. So we write here 2m1, and here m2 is also replaced by 2m2 divided by d square. Here F inverse is equal to 2 into 2 4, and here we can write its general form, that is G m1 m2 by d square. So that is F inverse is equal to 4 times of F. Here G m1 m2 by d square is F. Okay, so we have put here F inverse is equal to 4 times of F. When the masses of both bodies is doubled, then the gravitational force between such bodies increased by 4 times. Okay, in a result you can write the gravitational force is increased by 4 times when the masses of both bodies are doubled. Okay, this is the case of masses depend upon masses. Here distance remain constant. Okay, and next topic, that is we discussed change in the gravitational force due to the variation in distance, but here mass remains constant. Okay, and I am going to keep them same. Okay, I am going to make changes. This is B number, and force in the variation due to variation in their distance due to the variation in distance between them, due to variation in distance between them, but their masses remains constant. Here condition 2. Okay, here condition 2, that is change in the gravitational force due to variation in distance between them, but here masses of two bodies remain constant. Masses of two bodies remain constant. Here same thing we are going to do here. That is, consider two bodies having the mass m1 and m2 respectively, okay, which are separated by the distance d. Okay, they let these two bodies of masses m1 and m2 and the distance between them is d. So according to the Newton's universal law of gravitation, the gravitational force between them is given by F is equal to g m1 m2 by d square. Okay, so now we going to study two cases in this under this distance topic also. That is, first case, when the distance is doubled, okay, the distance between them is doubled. The distance between them, body A and body B. So we do the thing here is, when D is replaced by 2D, when D is replaced by 2D, then we share F inverse is equal to capital G m1 m2 by 2D square. 2D square. Here D is replaced by 2D, so we have put here 2D whole square. Here that is F inverse is equal to G m1 m2 by 4D square. And here we write F inverse is equal to, okay, here we can write F inverse is equal to 1 by 4 G m1 m2 by D square, which is F1 inverse is equal to 1 by 4 of F. That is, when the distance between them is doubled, then the gravitational force between such bodies is decreased by 4 times. Okay, now we study second case, that is when the distance is halved. When the distance is halved, here the distance is d, then bodies having the distance becomes d by 2, A body and body B. So in this case we have, when distance d is replaced by d by 2, then what we get here, then we get F inverse is equal to G m1 m2 by, and instead of d we write here d by 2 square. That is, F inverse is equal to G m1 m2 by d square upon 4. We write here F inverse is equal to, F prime is equal to what? G m1 m2 by d square, and this 4 goes up, so into 4. That is, F inverse is equal to 4 times of F. Instead of this we have put here F, and here this 4 comes here. Okay, so when the distance is halved, then the gravitational force between such two bodies is increased by 4 times. Okay, in this way we have completed our first topic, that is change in gravitational force due to variation in their masses and distance between them. Okay, now we discuss about acceleration due to gravity. This is our next topic. Now we go to our next topic, that is acceleration due to gravity. Acceleration due to gravity. Suppose this marker is moving with the velocity, some velocity, this something, and when I apply force here, then its velocity increases. That is, change in velocity takes place. Okay, its velocity changes when I apply force. Similarly, while falling downward, means while falling, suppose I lift this marker from a certain height here, then this marker fall down, and there also its velocity also changes due to the effect of, that is, gravity. Okay, the velocity of this falling marker also changes due to the effect of gravity. Okay, and when there is change in velocity, then this is responsible for acceleration. Change in velocity is responsible for acceleration. Thus, we can define the rate of change in velocity. The rate of change in velocity in a freely falling body under the effect of gravity only is called acceleration due to gravity. Acceleration is produced due to gravity, so this is termed as acceleration due to gravity. Since it is the acceleration, its unit remains same, that is meter per second square. Once again, I am going to make you clear. Suppose when I lift this marker, then this marker falls down and its velocity also changes with time. This change in velocity is responsible for producing acceleration. This change in velocity is responsible for acceleration. So the rate of change in velocity in a freely falling body means just falling. Now you understand, just falling, okay, without resistance. We will discuss in our next lecture. Okay, freely falling body, the rate of change in freely falling body under the effect of gravity only is called acceleration due to gravity. Okay, now we write here its fair definition. The rate of change in velocity under the effect of gravity only. The rate of change in velocity of which body? Velocity of freely falling body. The rate of change in velocity of a freely falling body. The rate of change in velocity of a freely falling body under the effect of gravity only is called acceleration due to gravity. Okay, and this is denoted by small g. It is denoted by small g. Since this is the acceleration, its unit remains same, that is meter per second square. Its unit is the unit of acceleration, unit of acceleration, that is meter per second square. This is the unit of acceleration. Okay, we have understood about this acceleration due to gravity. And there is the formula of acceleration due to gravity, that is small g is equal to g m by r square. Now we prove this formula. Okay, let me draw this. Let the body of mass small m is on the surface of the earth having mass capital M and radius capital R. Okay, let body of mass m is on the surface of the earth and having mass m capital M and radius small m, means capital R. Suppose this is earth and its radius is capital R. Suppose one body is here having mass small m. The mass of this earth is capital M. Okay. Let one small body is on the surface of this earth, which has mass capital M and its radius is capital R. Now we know force of, according to the Newton's universal law of gravitation, according to Newton's universal law of gravitation, according to the Newton's universal law of gravitation, gravitational force between this gravitational force between a small body and the earth is given by F is equal to G capital M small m by r square. Okay, here according to Newton's universal law of gravitation, we know F is equal to capital G m1 m2 by d square. Here m1 is capital M, that is mass of earth, and m2 is small m, that is mass of body, and the distance between these two bodies is r. When you stand on the surface of the earth, then your distance remains same, that is that of the distance means that is equal to the radius of earth. Here let this equation be 1. And according to the Newton's law, second law of motion, we know that is F is equal to ma, the magnitude of, we know according to Newton's, F is equal to mg. So we know here that is mg, this is a small m, this small mg is equal to capital G capital M small m by capital R squared. Now we can, since this small m have age same, yes, we can cut this small m and we can write here g is equal to capital M by r square. Here the masses of this body and this body is same, so we can cut this. The body is same, so their masses is also equal. Here then we get g is equal to capital M by r square. It means the acceleration due to gravity is independent of the shape, size, mass of body. It means it only depends upon the mass of heavenly body, that is earth, and the square of means radius of such body. So we can write here g only we can write here g is independent of mass, size, and shape of the body. It means acceleration due to gravity is independent of the shape, size, and mass of such body, that is this body. When you have to find the acceleration due to gravity of any planet, then just take the mass of such planet and radius of such planet. Okay, then you can calculate the value of g, small g. From this we have written this g is independent of the mass, size, and shape of the body. So we have finished these two topics. Now we discuss one question. Okay, you might have studied in your junior classes the value of acceleration due to gravity of the earth is 9.8 meter per second square. That is, the value of acceleration due to gravity of the earth is 9.8 meter per second square. What does it mean? What does it mean? See here. The acceleration due to gravity of the earth is 9.8 meter per second square. What does it mean? What does it mean? Acceleration due to gravity of the earth is 9.8 meter per second. What does it mean? Then you answer this question as this. It means the velocity of the body is increases by 9.8 meter per second. 9.8 meter in every second. Okay. It means the velocity of falling body increases by 9.8 meter in every second. Every second. Okay. It means the velocity of falling body increases by 9.8 meter in every second. It means when I lift this lid of marker, then its velocity increases every second. It means its velocity in 1 second becomes 9.8 meter, okay, per second, and in another second its velocity becomes twice. In another second its velocity becomes thrice. Okay, similarly in this way its velocity increases. In this lecture, we have discussed two topics, that is change in the gravitational force due to the variation in their masses and the distance between them. And next topic is acceleration due to gravity. Under the acceleration due to gravity, we have only discussed about its definition and its derivation formula. Okay, and one very important question. So for this lecture, only this much. Thank you for today.